All right, we did it. Not only is this the last video of day 10, it's the last video of our programming section of the course. When we're done with this, we've done the biggest and earliest section of the course where we've done all the functional programming we're going to be doing in Galena in Coq. So congratulations, you're almost there. You're so close to done. You've learned quite a bit. Think about where we started when I showed you those funny definitions for day and bool and nat. And you were like, who is this guy? What does he think he's doing here? And now you're writing a compiler. Day 10. Incredible. Let's do it. So, what do we want you to do here? We want you to write a function scompile that takes an arithmetic expression and produces a program for a stack machine. You'll notice we don't take any state because your compiler doesn't need to know the value of variables to emit the correct program. You'll just emit correct instructions, for example, to load variables. So the trickiest bit here, I think, is argument order. There's sort of like a trick to what you want to do in general, and then you have to get the argument order right, and then everything will fall out. So like once you've figured it out, once you've got the secret, this is an easy function to write. Figuring out that secret might take you a little bit. So we can give you one more hint. If you think of aexp as a tree, this is a post-order traversal. Right? That's how your compiler is going to work. So just to give you an example, you're going to want to write more yourself. What's nice is you can test it because you have an evaluator for arithmetic expressions and you have an evaluator for these programs, so you should be able to make sure that your programs are behaving the same in similar states. But here's one that I'll just walk through with you really quickly, just to make sure you've got all the gist of it. If we compile this program, x minus 2 times y, you should get out something that looks a bit like this. Let's look at what the program does. It loads x onto the stack. It pushes 2 onto the stack. It loads y onto the stack. It multiplies the top 2 things on the stack. Well, what's that going to be? That's going to be y and 2. And so then the next thing on the stack we'll have will be whatever 2 times y is. And then it does the subtraction, which will compute x minus 2 times y. So if you look at this, inside this example is the nugget of that core idea. You can see the sort of post-order traversal happening. You might have to think about it for a bit, do some examples, play around. Once you get it, you're going to know that you've got it. And then lastly, you can print this out, hang this on your wall as just like an official certificate that you, when you're done with this, will be a compiler writer. Welcome to the club. Nice to have you. Okay, questions about this on Zulip? These hints are just about everything I want to say. I want you to really think about this pretty carefully. But if you're really stuck, bring a question to me. The worst case I'll do is I'll give you another test case or something. I would love it if y'all want to share test cases that you thought were insightful online. I think that'd be really helpful for other students. You can even share what you think they ought to go to. What I don't want you to do is to share details of this program. I really think that it's valuable for everyone to figure this out on their own. Okay, that's the end of day 10. It's been quite a ride. I really look forward to next week when we'll get to start doing some proofs, and this is going to get really interesting. We'll see a whole new side of Coq, and we'll get to really sort of dig deep into what your programs mean and how they work. I think it's gonna be a lot of fun. See y'all soon.